Welcome back to JEE Advanced Aspire. My name is Shimon Joseph and I'm your math master teacher at Vedantu. So guys, today we'll be looking at complex numbers, and that is so because a lot of you have requested in your YouTube comments that we'll have to do complex number once again as a revision. So let us see some interesting questions, and we'll also address the homework question which I gave you last time. And many of you rightly pointed out there was a small mistake in the question. Not a mistake, it was a typo. Let us correct it today and solve it. Okay. So let's dive right in, and before that let me show you something about Aspire. The maths part of Aspire is taken by Pulkit sir, myself and Arvind Sutar sir, and then the Aspire program is for 5 weeks. It's meant for JEE Advanced, and towards the end, to intensify it, we have something called as the last mile board. So do take part in it and benefit from that. Okay. So let us see the first question. So this is the homework question which we saw in the last class. So I hope all of you can see the question. I'm not blocking anything. So please do read it, pause the video, try it out, and then come back. Let us discuss it together. Okay. So now let me get started with the solution part of this. So but before that, let me explain the question and see and tell you guys what is the mistake. So here we have given f of x is a function of the form alpha z plus beta, where alpha and beta are what? They are constants which are complex numbers as well. Okay, so please don't think alpha and beta are real numbers. They can be complex also. Where is it said so? It is said so over here. Got it? Now what else do we know? We know that mod of alpha is not equal to mod of beta. What do you mean by that? The magnitude of complex number alpha is not equal to the magnitude of complex number beta. Now that is not enough for me to solve this question. I don't have any idea about the function. Only thing which I know is it is equal to alpha z plus beta. That is the form of the function. But what is alpha? What is beta? And what do I do with it? I am not sure. So that is when the next part of the question will help. What is the next part of the question? It is said that if the imaginary part of z is non-zero, then f of z plus f of z the whole bar, this is not plus, it is equal to. Okay, so that is the typo which I was talking about in the comments, and many of you rightly pointed out. Good job guys, that is brilliant. So please make this correction and then try it out. Pause the video right now. I will continue with the solution part of it. Okay, so this is the first information, and you have second information, and you have the third information as well. Now using all these three, we need to find out what will this equation represent. Got it? So I am sure using these three information, I will have some picture about alpha and beta. Now that is used to solve the question. I am sure all of you have got that. So please do give it a try now that you know the question. You just have an equal to sign here. It is not plus anymore. Please correct that guys. Okay. So let us come to the next part. I am going to solve it over here. So listen carefully everyone. So first thing is, let me write down the function. The function is of the form f of z is equal to alpha z plus beta. Okay. So now I will read the first information. Imaginary part of z is non-zero. Okay. If it is non-zero, then this is equal to this. So let me write down what is f of z. F of z is what? Alpha z plus beta. Okay. Now what is f of z? The whole bar. So f of z the whole bar will be applying bar to everything inside z, or everything inside f of z. So f of z contains what? Alpha z plus beta. When I apply the whole bar, that is conjugate, I will take alpha bar, z bar plus b bar. Is that clear? Now that will be equal to f of z bar. So what is this? The function's argument is changing from z to z bar. So I will write this z as z bar. That is the only change. So that I will write it down over here. Alpha z bar plus beta. Plus, what is the last one? The last one is the conjugate of the f of z bar function. Got it? F of z bar. I am going to take the whole conjugate. So when I take the whole conjugate of this, what will happen? I will get alpha bar z plus beta bar. That's it. Done. Now I have to get a relation between alpha, beta, whatever it is. I can say directly that beta and beta bar will get cancelled. Beta and beta bar will get cancelled. I'm sure all of you are clear with that. Isn't it simple? Now let us collect the terms and see what is happening. So I will collect alpha, you will get z minus z bar. Then I will collect alpha bar, I will get z bar minus z is equal to 0. Now I want to keep it as z minus z bar. So what will I do? I will take a minus out from here. So guys, watch carefully. This will change to alpha into z minus z bar minus of alpha bar into z minus z bar equal to 0. Why did I do that? Because I want to make these two equal and take it out as a common factor. So here z minus z bar is common to both these terms. So I can take it out as a common factor. Are you all with me? So let us do that. I will take z minus z bar to be common factor. What is left out? Alpha minus alpha bar is left out. So these are the two factors whose product is going to give me 0. But guys, wait a minute. Imaginary part of z is non-zero. What does that mean? Any idea? Please think about it. I'll give you a small pause here for a minute. You guys can think about it and let me know, what does imaginary part of z being non-zero mean? Okay, so let me take z. So let us say our z is of the form a plus ib. Okay, so let us say z is of the form a plus ib. So what is z bar? Z bar is a minus ib. So when I do z minus z bar, what do I get? Z minus z bar will give me 2ib. Now, if the imaginary part of z is non-zero, that means what? B is non-zero. If B is non-zero, can I say that z minus z bar will also be non-zero? Is it not? Can I say that z minus z bar will also be non-zero? That is absolutely right. That is absolutely right. So if that is non-zero, that means this term cannot be 0. But the product is 0, right? If this term is not 0, the product is 0. So what can I say here? I can say that this is equal to 0. So alpha is equal to alpha bar. And guys, can anyone comment? What do you mean by saying alpha is equal to alpha bar? Any idea? Yes? No? So when you say alpha is equal to alpha bar, that means alpha is a real number. As simple as that. Okay? So why do we say that? Can anyone tell me? Again, go back to the same logic. Alpha is a complex number, right? So assume alpha is of the form x plus iy. So if x plus iy is equal to x minus iy, then what can you say? The imaginary part is 0. So it is a purely real number. Got it? So alpha is a purely real number. That is the result that I get from the first part. Okay, so can I erase it? I hope all of you are clear. So if not, please go through the recording, guys. We need to solve some questions, so I'm going to go a bit faster. You have to keep up the pace with me. Got it? So alpha is equal to alpha bar is a result from the first one. Let me erase all of this. So the first one, when I say it's equal to, it gives me alpha is equal to alpha bar. That means alpha is a purely real number. That means what? I can take alpha to be a, where a belongs to real numbers. Got it? That's the first result. Now let me go to the second part of this. From the second part, what do I get? It is said that if real part of z is equal to 0, then f of z plus f of z, the whole bar, is equal to 0. So from that, what do we get? Let us have a look at it. So f of z is nothing but alpha z plus beta plus f of z, the whole bar, is nothing but alpha bar z bar plus b bar is equal to 0. Now guys, we know that alpha is equal to alpha bar. So can I say that alpha bar is equal to alpha? Yes. So let us say that alpha bar is equal to alpha. Now I can take alpha to be common. So if I take alpha to be common, I will get z plus z bar plus b bar is equal to 0. So I'll get alpha times z plus z bar plus beta bar is equal to 0. Everyone clear with that? Done? So now what is given here? The real part of z is 0. So if the real part of z is 0, what else do we know? We know that z plus z bar also will be 0, because what do you get when you evaluate z plus z bar, guys? So z plus z bar, as I said, if you take z is equal to a plus ib, what is z bar? Z bar is equal to a minus ib. So z plus z bar will be equal to how much? Will be equal to 2a. Now in the second part of this question, I have if real part of z is 0. If the real part of z is 0, what do you mean? We say that a is 0. So if a is 0, z plus z bar is 0. Are you all clear with me? Got it? Perfect, guys. So now after I know that this is 0, what do I get? I get beta plus beta bar is equal to 0. So if beta plus beta bar is equal to 0, right now we saw whenever beta plus beta bar, a complex number, is equal to 0, then the real part of beta is 0. If the real part of beta is 0, it means that it is a purely imaginary number. So beta is equal to minus beta bar is a purely imaginary number. Okay? So guys, you must be aware of this. These are very basic things. So z plus z bar equating to 0 because real part of z is 0, and beta plus beta bar because it is 0, I am using the converse here. What is the converse? If beta plus beta bar is 0, then I know that it is a purely imaginary number. Are you guys following? So that is how we solve this. So that is the result from the second statement. So let me write that down. So the crux of the second statement is going to be beta being a purely imaginary number. So let me erase all of it. So what do we have here? Beta is equal to minus beta bar. So beta is equal to IB, where B belongs to real numbers. I hope all of you agree with me. Why did I write beta like that? Because when I say beta is equal to IB, where B is a real number, I am indirectly saying beta is a purely real number. Purely complex number, purely imaginary number. Okay. So beta is equal to minus beta bar implies beta is equal to IB. Now B is belonging to real numbers. Why did I write it like that? The reason I wrote it like that is because I want to exhibit the fact that beta is a purely imaginary number. And that is the same reason why I wrote alpha is equal to A. And A belongs to real numbers, because we are all very familiar with A, B, small b being real numbers, right? So when I write it like that, it's a bit comfortable for me to work with over here. You will understand it in a moment. Okay guys, is that clear? So those are the important observations you can make from the first and second statement. Now let us go to the third one. So what does the third one say? The third one says that if my z is real, then f of z bar into f of z is equal to, is greater than z plus 1 the whole square. So let us write that down. So alpha z plus beta into alpha bar z bar plus beta bar is greater than or equal to z plus 1 whole square. Z is a purely real number. Okay, Z is a purely real number. It is given here. In this condition, okay, if Z is real, then this is holding true. Because you might have noticed, right, the first thing which your teacher might have taught you when starting off with complex numbers is that complex numbers do not follow inequalities. You cannot compare complex numbers. Is it right? You cannot compare complex numbers. That's absolutely right. But here, why are you doing that, sir? Z is a complex number. No, it's given in the question. But look at the third subdivision. What are they saying? If Z is real, then this is true. Okay. So the Z we are talking about over here is actually a real number, and that is why I have inequalities in them. Now you can ask me, but what about left hand side, sir? Alpha is there, beta is there. Beta is a purely imaginary number. Then you can have left hand side alone in imaginary numbers. Is that correct? No. You didn't wait. You have to open it and then see. Okay. When you open it and see, what will you get? you will get a purely real number on the left hand side also. Let us do that. Okay. So what is alpha? I will replace alpha with A and Z plus beta. What is beta? Beta is IB, right? So I'll write plus IB. And then what is the left side? I'm sorry, what is the second factor? The second factor is alpha bar. Alpha bar can be written as A again, because for a real number, whether you take conjugate of it or you have the same complex number, it is going to be the same. And then Z bar is Z only. Why did you write Z bar as Z? Because in the third subdivision, it is given to be real, right? So if it is going to be given as real, then Z and Z bar are the same. Plus beta bar will be minus IB, because conjugate of beta will make sense because it is a purely imaginary number. Got it? Now that will be greater than Z square plus 1 plus 2Z. Is that clear, guys? Now let me erase this part because I don't have space to solve. Now this is A plus B into A minus B. So what is A plus B into A minus B? It is nothing but A square minus B square. So minus of I square B square. So minus of I square will become plus. So it will become plus B square is greater than Z square plus 1 plus 2Z. Now I will write it in a short form by combining the terms. Alpha square minus 1 Z square minus 2Z plus B square minus 1 is greater than 0. Got it? Yes. So this is the last condition that I have. Okay. Now with these three conditions, let us try to solve our questions. We are all set to solve it. Now I am sure all of you will be able to solve it because it's quite easy after this. I am sure all of you would have figured that out. Let us go to the first question. So what do we have here? Let me write it down here because we have some space. Okay, let us start off our discussion from here. So we have 4x squared by f of 1 minus of f of minus 1. What is f of 1? F of 1 is alpha into 1 plus beta, because the variable here is z, right? So wherever z is coming, I will put 1 minus. So minus f of minus 1. What is f of minus 1? Wherever z comes, I will put minus 1. So beta will be cancelled. You will have 2 alpha. Okay. So whole square is there, right? So it is going to be whole square of this. So which is going to be 4 alpha square. So it will be 4x square by 4 alpha square. 4 will get cancelled. We have x square by alpha square. Now let us do the y part. So plus y square by f of 0. What is f of 0? F of 0 is beta. And beta we know is nothing but IB, right? Beta we know is nothing but IB. So what is IB the whole square? IB the whole square is minus 1 b square equal to 1. So this equation reduces to x square by alpha square. Alpha is equal to a, right? A is a real number. Let us talk about real numbers only. Minus y square by b square equal to 1. So what is this? Was it difficult? We got such a simple equation, right? What is this? This is the equation of a standard hyperbola. Good question. So that is how we solve it. So the answer for this question will be a hyperbola. So if you are clear with this, let us move on to the next part of this question. You can take some time to go through this. If you have any doubt, please post it in the comments, guys. I will go through them. Okay, so please pause the video, go through it and let me know if you have any doubt. I am going to erase this and move on to the next part. So the next question, which is right over here, let us try to solve it. So what do we have? Consider an ellipse S which is given as x square by real part of alpha the whole square plus y square by imaginary part of b the whole square is equal to 1. So what is this equation? What is the real part of? Okay, what is the real part of alpha? Real part of alpha is nothing but a. So x square by a square plus y square by imaginary part of beta. Guys, here they are not asking beta directly. They are saying imaginary part of beta. So what is the imaginary part of beta? The imaginary part of beta is nothing but b. Because I took beta to be equal to IB. Now imaginary part alone if they ask, it is going to be b. Got it? So it is going to be plus y square by b square is equal to 1. So this is a proper ellipse, contrary to what we got earlier. See, earlier and this case is different because what is defined here is different. There we had f of minus 1, f of 1, and then here we had f of 0. But now we have clearly real numbers because they are asking real part of alpha and they are asking imaginary part of beta. Both being real, you get a standard ellipse equation. Now, that is not the question which they are asking. They are saying, if this is an ellipse, then will the point 1, 1 lie inside or outside or on this ellipse? That is what you have to figure out. Now guys, you have to go back to coordinate geometry because there is a simple concept involved here. What is that? How do you find the position of a point with respect to a curve? So whenever my S1 is greater than 0, it will lie outside the curve, and whenever my S1 is equal to 0, it will be on the curve, and whenever my S1 is less than 0, it will be inside the curve for an ellipse. Got it? For ellipse, parabola, circle, it follows the same thing, but for hyperbola alone, the sign will be reversed. Okay guys, I'm sure all of you are aware of it. So S1 is nothing but the value obtained by substituting the point 1, 1 in the line equation or the curve equation. Got it? So whenever I substitute 1, 1 in the curve equation, whatever value I get, that is nothing but my S1, and if S1 is greater than 0, it will be outside. If S1 is equal to 0, it will be on, and if S1 is less than 0, it will be inside. Is that clear? So let us figure out what is our S1. Now what will be my S1? My S1 will be 1 by a square plus 1 by b square minus 1. So this is my S1. Now if I look at it directly, I have no idea what is happening here. Is it not? Because I can't predict whether this will be greater than 0 or less than 0. Got it? But go back to the third condition which we obtained. If you guys made a note of it, please refer to it as I am writing it down. So the third condition which we got from here, if I am not wrong, is alpha, it's not alpha, it's a square minus 1 times of z square minus 2z plus b square minus 1 equal to 0 is greater than 0, I'm sorry. So is this the condition that we got? Yes. So I have written it down from the previous slide. Please check if this is right. Okay. So we have a square minus 1 z square minus 2z plus b square minus 1 is greater than 0. So now we have a quadratic equation which is always greater than 0 for all z. Okay. So when can this happen, guys? I'm sure all of you are aware of it. When can this happen? This can happen only when you have imaginary roots, is it not? Because I want my quadratic graph to be always above the x-axis, and it is possible only when my coefficient of x square is positive as well as my discriminant is less than 0. So let us solve that. Let us keep our discriminant to be less than 0 and see what is happening over here. So if my discriminant is less than 0, what do I get? B square minus 4 times of b square minus 1 into a square minus 1 is less than 0. So when I say my discriminant is less than 0, what do I get? I can cancel off these two 4's, I'll get 1 and 1. So let us solve that. So you'll get 1 minus a square b square plus a square plus b square minus 1 is less than 0. So I can cancel off these two ones. Okay. So guys, the alpha here is nothing but a, because alpha is a purely real number. I hope you guys remember that. Now, can I divide by a square b square? Can I divide by a square b square? I know both of them are positive, so I can do that. So when I divide by a square b square, what do I get? I'll get minus 1 plus 1 by a square plus 1 by b square is less than 0. So I will get 1 by a square plus 1 by b square minus 1 is less than 0. So what do I get? Good. So did you all understand? So the point lies inside the ellipse. That is the answer for this question. I hope all of you liked it. And if you have any doubt, do post it in the comments. So what I did here is I had a quadratic equation, and if my quadratic equation is always positive for all z equal to r, for all my z belonging to real numbers, my quadratic equation is always positive. That means my coefficient of z square must be positive and my graph should be above the x-axis always. So if it has to be above the x-axis always, it will have no real roots. If it has no real roots, then I can say my discriminant is less than 0. If my discriminant is less than 0, I get a very good condition which is directly going to give me the answer. Okay, so that is how you solve it, and the answer for this will be option B, inside the ellipse. Got it? So let us move forward to the next question. This is the homework which I gave. We have already spent a lot of time on it. Let's go forward. Now coming to the next question, another interesting one. So here we have z1, z2, z3 as the vertices of a triangle having an area delta satisfying z3 minus z1. Guys, if you can't see it, please write it down as I am reading. z3 minus z1 is equal to 1 minus I root 3 into z2 minus z1. That is the first equation which they have given, and we are also given that root 3 times of mod of z2 minus z3 the whole square is equal to k times of delta. Now tell me what is the value of k. That is what they are asking. So here it's a very good application of rotation of complex numbers, guys. Okay, so right now is the time to pause because I'm going to start off with the solution part of this question. Okay, good. So let us discuss this from scratch. Okay, so I'll start from the condition which is given here. So I have z3 minus z1. I will take this to the other side. So what will I get? I will get z3 minus z1 divided by z2 minus z1 is equal to, guys, can I multiply and divide by 2? I will multiply and divide by 2. Now, don't you think this is cos of minus 60 degree plus I sine minus 60 degree? How many of you agree with me on that? So whatever we have here, 1 by 2 minus I root 3 by 2, that's a complex number. And why did I divide by 2? Because I wanted to take modulus separately outside and keep a unit modulus complex number inside. Okay, this is a unit modulus complex number, right? So that is the reason I took this 2 outside. Is that clear? Now this 1 by 2 minus I root 3 by 2, I can write it as cos of minus 60, because cos of minus 60 will again lie in the fourth quadrant and we know the value of it is 1 by 2. So it is going to be positive half. Now plus I sine minus 60. Now sine cannot be positive in the fourth quadrant. And why do I keep saying fourth quadrant? Because minus 60 is in the clockwise direction. So if I go 60 in the clockwise direction starting from x-axis, I go to the fourth quadrant. Okay. So that value will be negative, and we know what is sine 60. Sine 60 is nothing but root 3 by 2. And am I getting it? Yes. So it is perfectly fine to do that. So now this thing can be written as e to the power minus I pi by 3. Is it the same? Cos of minus 60 plus I sine of minus 60 can be written as e to the power I minus pi by 3. That's exactly what I wrote. So the best part of this is I can erase all of it and write this as, that's it. Okay, so that is how you solve this question. I'm sure some of you have got the hint now. So this is a proper rotation based question, guys. Why is it rotation based? Now what is the rotation formula? So if I rotate about z1 as pivot, so if I have z1 as the pivot, pivot means about which I rotate. Got it? So if I have z1 as the pivot, I can write this rotation as this one. I'm sure all of you are aware of it, into e to the power minus I pi by 3. Because pi by 3 is the angle between them. So from this I know that the angle between them is minus pi by 3. So I have written it clearly. So what is this 2? This 2 is nothing but the ratio of their respective modulus. This 2 is nothing but the ratio of their respective modulus, that is mod of z3 minus z1 divided by mod of z2 minus z1 is actually 2. Is that clear? So let me write it in a graphical form so that all of you can understand. So here is Z1. Now here is Z3 and here is my Z2. So this is Z3 minus Z1. This is Z2 minus Z1. Now usually how do we write it? Wherever the arrow points, I write that first. But unfortunately here I am moving in the clockwise direction. So I reverse it and write. So this angle is pi by 3. Okay. So I hope all of you got it. So in a argon plane, the representation will be looking similar to this. So you have Z1 as a pivot because I am rotating about Z1, and the angle about which I rotate is pi by 3 from here. Now I have minus pi by 3. What does that mean? That means I am going in the clockwise direction as opposed to anti-clockwise. So whenever you go anti-clockwise, you take it positive, and whenever you go clockwise, you take it negative. So if I went anti-clockwise, I would have put Z3 here. Are you all getting it? Because it is clockwise, I put Z2 over here. Okay. I hope all of you are following. So if you are not getting it, I will just give you a simple example. So whenever you have a rotation like this, so let's say theta. So now theta is in the anti-clockwise direction. Theta is in the anti-clockwise direction. Is that clear? Now the rotation for this, how will I write it? I will write it as Z2 minus Z1. I will always write where the arrow points to first. Okay guys, wherever the arrow points to first, I will write that, and then I will divide by Z3 minus Z1. That will be equal to the ratio of their modulus. What is the ratio of the modulus? Mod of Z2 minus Z1 divided by mod of Z3 minus Z1 into e raised to the power I theta. That's it. That is all about rotation guys. It's very simple. Just follow this rule, you will never go wrong. So what did I do? I had the pivot. Obviously the pivot is required because about that only I keep rotating, right? So I need to have the pivot which is Z1. So first I will mark the angle in anti-clockwise direction. Always anti-clockwise. Got it? So I mark it in anti-clockwise direction. Wherever the arrow is pointing to, I will write that first. Z2 minus Z1 divided by Z3 minus Z1 is equal to modulus of both of them, the ratio, into e to the power I theta. Now, can you compare these two? I hope all of you are able to get it. Now, here I have something else. Here I have something else because I have minus pi by 3. Contrary to what I have as theta, I have minus pi by 3. That is why even though I have Z3 minus Z1 on the top, I still put my arrow on Z2 because angle measured is negative. Got it? Although it doesn't matter much to this question, even if you put it wrong, you will get the same answer. Still, I want you guys to be conceptually correct. Don't make mistake in the way you plot it. I hope all of you have got it. If you have any doubt, let me know in the comment. I will probably explain it in writing. Okay. So let us come back to this question. So let me draw a triangle. Now these three can represent a triangle. So you have Z1, you have Z2, you have Z3. Now let us say this distance is X. Now if this distance is X, what is the ratio 2? Ratio 2 is Z3 minus Z1 by mod of Z2 minus Z1 equal to 2. So what does this mean guys? This modulus is nothing but distance between these two. So mod of Z3 minus Z1 is nothing but this distance. Mod of Z2 minus Z1 is nothing but this distance. So I took this distance as X. So can I substitute instead of this place? I will divide by X. So if I take this as X, what will be mod of Z3 minus Z1? That will be 2X. So that will be 2X. So this distance, that is mod of Z3 minus Z1, will be equal to 2X. I am sure all of you are able to follow. Now, we also know this angle to be 60 degree. Now, I will use cos rule. What is cosine rule? I will take this side to be Y. I know that my cosine rule says cos of 60 is equal to x square plus 4x square minus y square divided by 2 into 2x into x. Got it? So I'll have 1 by 2 is equal to 5x square minus y square by 4x square. So you get y square to be equal to 3x square. That's it, done. So my y square is equal to 3x square. That is one relation. Got it? And that relation will be used in solving the question, because what is our ultimate aim? Our ultimate aim is to find the value of k. So if I have to find the value of k, I need to get mod of z2 minus z3. Is mod of z2 minus z3 given to me previously? No, not at all. I took it as y, right? Because I took it as y, used cosine rule and solved it, then I got y in terms of x. Got it? So now that is a pathway leading to our solution. So now I know what is my z2 minus z3 mod. What is z2 minus z3 mod? z2 minus z3 mod is nothing but y. It is a distance between them. Got it? So it is going to be root 3 y square is equal to k times of delta. What is delta? Delta is nothing but the area of the triangle. So what is the area of a triangle, guys? Are you all aware of it? Area of a triangle, I can write it using sine rule. So sine rule, if I write it, delta area is equal to half AB sine C, or you can say it as half product of adjacent sides and the included angle. Product of adjacent sides and the sine of the included angle. So half into product of adjacent sides into sine of the included angle, which is sine 60 root 3 by 2. So what is my area? My area is root 3 x square by 2. So it is going to be root 3 x square by 2. So x square will get cancelled if I convert y square to 3x square. Because what is y square? My y square is equal to 3x square, right? So I will remove y square and write it as 3x square. Now x square and x square will get cancelled. The x square over here will get cancelled. Root 3 will get cancelled. So what is my k? My k's value will be 6. Okay, so that is how you solve it. Again, it might look lengthy, guys, but it's quite easy to solve. In an exam, probably 1.5 minutes. That is the maximum time it will take to solve. The reason it gets delayed is because I want to explain each and every step so that all of you understand. Some of you might find it slow. I'm sorry, guys, but you have to probably watch it at a faster speed. You can go 2x, or you can even skip the portion of the solution which you find is easy. Okay, so that you can do. That is an option for all of you. You can do that in YouTube. But for those who are finding it slow, those who are finding it hard to follow, you can follow the natural pace of this class. Okay, so any doubts here, guys? If you have any doubts, let me know in the chat. I'll be there with you, or you can give me a comment. So let's move forward. Now this is an interesting question. So this is not lengthy, so I can solve it probably in 2-3 lines. But before that, I want you guys to try it out. All of you should try it out, because it's direct once you get the hang of it. Okay, so I'll read out the question for all of you. So here you have 1, alpha 2, alpha 3 till alpha 10 to be the 11 roots of unity. So 11th roots of unity. For example, z cube is equal to 1. You have 3 roots, right? 1, omega and omega square. So they are called as the cube roots of unity. So something similar to that, you have 11th roots of unity. Now if lambda is given to be as summation r equal to 1 to 10 r times of alpha r plus alpha 11 minus r, then what is the value of lambda plus 11 by 11? Okay, so I hope the question is clear to everyone. You can pause it right now, give it a try, and then come see me in the solution. Okay, so let's move forward and look at the solution part of this. So here, before we get started, so let's say z cube equal to 1. The roots are 1, omega and omega square. I'm sure all of you are aware of the fact that 1 plus omega square is equal to 0. Is it not? Now how does this come, guys? How is the sum of the roots of unity equal to 0? The reason is, if you have any polynomial equation, let's say an x power n plus an minus 1 x to the power n minus 1 and so on till a naught. This is my polynomial, let's say p of x. We know that the sum of the roots, let's say alpha 1 plus alpha 2 all the way up to alpha n, are my roots. The sum of the roots of a polynomial is equal to minus of this coefficient by an. Is it not? We have studied this in quadratic as well. Let us look at the example of quadratic. We have ax square plus bx plus c. What is the sum of the roots? Sum of the roots is equal to minus b by a. Is it following this? Yes, absolutely. So this is in general true for polynomial expressions. So let us apply that over here for the cube example. Okay, I'll erase all of this. Now that you guys are aware of it, let us come back to this example. In this example, what do we have? Z cube minus 1 equal to 0. So 1 plus omega square is equal to minus of coefficient of z square divided by coefficient of z cube, which is equal to minus 0 by 1. Z cube coefficient is 1. Is there any z square coefficient? There is no z square coefficient. For that reason, I put a 0 over here. Okay? For that reason, I put a 0 over here. So the sum of the roots is 0. And did we get it? Did we get the proof of it? Yes, absolutely. Now let's extend this to 11 roots. Okay, we are coming from basics. Let's extend it to 11 roots and see what is happening. So if I say z to the power 11 is equal to 1, then again the sum of roots 1 plus alpha 1 plus alpha 2 all the way up to alpha 10 will also be 0. Is it not? I'm sure all of you are clear with this. So let us get started. Now we can solve this question. So I will expand and write lambda. What is lambda? Lambda is equal to 1 into a1 plus a10 plus 2 into a1, a2 plus a9 and all the way up to 9 into a9 plus a2 plus 10 into a10 plus a1. Now, can I combine these two? So if I combine these two, what will I get? And then if I combine these two, what will I get? I will get 11 times of a1 plus a2 plus a3 all the way up to. So that is the expression you will be ending up with. Isn't it simple? You got such an easy expression. Are you all okay with this? So guys, I just expanded what is lambda. So lambda is r times of ar plus 11 minus r. So when it is 1, it is going to be 1 into a1 plus a10. When it is 2, it is going to be 2 into a2 plus a9 and so on. So when I sum all of it up, I will get something like this. But guys, wait a minute, don't tell this is 0. This is not 0 because we have 1 as well. But is there a 1 here? No, 1 is missing over here. So the sum of all the roots is equal to minus 1. The sum of all the roots apart from 1 will be equal to minus 1. So this will be 11 into minus 1, which is minus 11. So my value of lambda will be minus 11. So what is the answer? Minus 11 plus 11 by 11. The answer for this question is 0. Easy one, right? So that is how you solve this question. I hope all of you are clear. If you have any doubt, you know the procedure, just type it down. I will get back to you. Okay? So let us move forward to the next one, guys. So the next question, which is right on your screen. I'm sure many of you would have seen this very famous question, pretty frequently encountered. But anyway, I thought of discussing because it's pretty interesting to solve. Okay, so let us get started. You have mod z equal to 2, mod z2 equal to 3 and mod z3 equal to 4. Now, using that information, I want you to find out what is the value of this one. Okay? Clear? So these are the given conditions. Okay? What is given over here and then over here. Using these three conditions, you need to find out what is the value of this. That is the question. You can pause it right now. Try it out if you are encountering it for the first time. If you have already done this, you may skip this over, move on to the end of this video. Yeah. So let us move to the solution, guys. So the solution part of it, let us get started. The first one you have to observe is mod of z1 equal to 2. Okay. And mod of z2 equal to 3 and mod of z3 equal to 4. Now can I bring in mod z1 square here? So can I write this as 2 into 4 z2 z3 plus 3 into 9 z3 z1 plus 4 into 16 z1 z2. Can I write it like that? So what did I do? I wrote the 8 as 2 into 4. I wrote 27 as 3 into 9. And I wrote 64 as 4 into 16. There are reasons why I am doing this. You will observe it in a while. So what is mod z1 square? That is equal to 4. So that will be z1 bar equal to 4. Okay. Similarly, if I square this, mod z2 square is equal to 9, which means what? z2 bar equal to 9. And similarly the last one, z3 mod whole square equal to 16. So z3 bar equal to. So now wherever I have 4, I can put this, and wherever I have 9, I can put this, and wherever I have 16, I can put this one. That's it, done. Just solve it, get it. So you'll have 2 times of. What is 4? 4 is z1 bar. So I'll write as z1 bar into z1 z2 z3. Then plus 3 times of. What is 9? 9 is z2 bar. Now I'll take z2 bar common, and then I'll get z1 z2 z3 again. Then the last part plus 4 times of. What is 16? 16 is nothing but z3 bar. Now I'll take z3 bar in the front and I'll have z1 z2 z3 whole raised to the power 1 by 3. Got it? So now what is common here? You have z1 z2 z3, z1 z2 z3, z1 z2 z3. So obviously I will take that common. Whole raised to the power 1 by 3. Because when I take it common outside, this 1 by 3 will attach to that as well. Got it? So what is left out? Apart from this, you will have 2z1 bar plus 3z2 bar plus 4z3 bar whole to the power 1 by 3. Now guys, you can see very clearly the bar is attached to all the terms inside. So can I say it is whole bar? Can I say it is 2z1 bar plus 3z2 plus 4z3 the whole bar? I can say that because I had z1 bar, z2 bar, z3 bar. I can take it to be whole bar as well, right? Whenever I apply a whole bar, it will be applied to each and every term. So if I apply bar to 2, no difference. 2 bar and 2 is the same thing. That is what I had previously. So there's nothing wrong in doing this. Now what is the best part about doing this? The best part about doing this is we know that mod z is equal to mod z bar. I hope all of you know that. Because z and z bar are nothing but reflections about the x-axis or reflection about the real axis. So when you are taking reflection about the real axis, their distance from the origin is not going to change. Okay, so whenever you take reflection about the real axis, my distance from origin is not going to change. Therefore, mod z is equal to mod of z bar. So instead of mod of this thing, the whole bar, can I say it is equal to mod of the inside quantity? I can say it is equal to the mod of the inside quantity. Yes, because mod of z bar can be written as mod of z. That's what I did here. Now what is mod of z? We have it here, right? What is that? Something but 9. That's it, done. So this is 9 to the power 1 by 3. And mod of z1, z2, z3 whole power 1 by 3 can be written as mod z1 power 1 by 3, mod z2 power 1 by 3, mod z3 whole power 1 by 3. So you'll have 2 into 3 into 4 into 9 whole to the power 1 by 3. What is that? 6 into 36, 216, 216 to the power 1 by 3, 6. So 6 will be the answer for this question. I hope all of you got it. Yes? So guys, if you have any doubt, let me know in the comment. I will sort it out for you. So this is a pretty interesting question. A simple application of how to use mod z square is equal to zz bar. Okay. So let us see what is the next one. Now the next one is a geometrical question. So what are they asking here? the number of points of intersection of the curves represented by argument of z minus 2 minus 7i is equal to cot inverse of 2 and argument of, what is given over here? Argument of, guys, this is not equal to, let me just erase it. Okay, that is not equal to. So it is the argument of z minus 5i in the top by z plus 2 minus I. That is equal to plus or minus pi by 2. Now guys, I hope all of you know what are these meanings and how they are curves. You should be understanding what is meant by curves. That is, I see no curve here. I see no curve here, but when you understand the interpretation of this, you will get the representation right. Okay, you should understand what is given over here. So let us try to have a look at it. If you want to try it out, please pause it. Now is the right time. I hope I'm not blocking anything. You have the questions clear, you have the options also clear. Try it, come with an answer, and then look at what I'm doing. So let's go to the next solution part. Yeah, here I will solve it here. So guys, the first thing is, I'll erase this, it's not equal to. Now I will solve this one first. For that I will draw the Cartesian plane, or I'm sorry, we are talking about complex numbers, so I'll draw the Argand plane here. So this is my real axis and this is my imaginary axis. So I have z minus 2 minus 7i, right? So where does that point lie? That point is 2 comma 7. Let's say 7 is here. So this is my point. So whatever z I take, the angle subtended by the line joining z to this point should make an angle of cot inverse of 2 with the positive direction of x-axis. How many of you got that? That is the meaning of what is given over here. So this is going to be a line segment. Okay, I'm sorry, not a line segment, it is going to be a line ray, a ray of line. So it is going to be a line ray based on the definition given here. Why is that so? Let us have a look at it. So if I take a point z here, when I join this to the point 2 comma 7, that will make an angle theta equal to tan inverse of 1 by 2. Why did I write tan inverse of 1 by 2? Because cot inverse of 2 can be written in this way. Now tan inverse of 1 by 2 is an acute angle. That also matters here. You will see in a while. This is an acute angle, right? So I am drawing it in such a manner. Now whatever point lies on this line will always make the same angle. Now you can ask me, sir, why not the other way, sir? Why don't we take this way? Why only a ray? Why not a line? The line is not possible because when I take it like this, and if I find argument of z minus 2 minus 7i, I will get the angle this one. Now this angle will no more be acute. So that is wrong. Is that clear? So the angle which they have given you also matters a lot, and how it is measured is also of prime importance in this question. I hope all of you are clear. Now coming to the second part of this question. The second part is interpreting this. Now guys, I have already taught you in the previous class, whenever you have argument of one complex number minus another divided by one complex number minus another, then you will have on the right hand side a constant number. It will always be a circle or a part of a circle, is it not? So whenever you have a question like this, let me write it down for you. So if you have whenever you have argument of z minus z1 by z minus z2 equal to alpha, then it always represents a part of a circle depending on what value alpha takes. If alpha is acute, it will represent major segment. If alpha is obtuse, it will represent a minor segment of the circle. Is that clear? I hope all of you are getting that point. Now, acute, major segment, obtuse, minor segment. So what if it is exactly 90? What if it is exactly 90? It will represent a semicircle. Got it? So Here we have plus half and minus half as well. So what will be? It will be the top semicircle and also the bottom semicircle. So it will represent a complete circle. Okay. So it is going to represent a complete circle, that is the locus of the second equation that is given to you. So let us get started. So here what do we have? About 0, 5. So minus 5i, right? So it is 0, 5. So 0, 5 will be over here. And then what is the other point? You have minus 2 plus 1. So you have minus 2 plus 1. Now these are the endpoints of my diameter. Because about these 2 points I am subtending right angle, right? From these 2 points on Z I subtend a right angle. So these are the endpoints of my diameter. So what will be my center? My center will be 1, 3. I'm sorry, minus 1, 3. So my center will be minus 1, 3. I can draw a circle here, right? So something like this. So are they intersecting? There is no point of intersection. So the answer is 0 for this question. Is that clear to everyone? So since there is no point of intersection between the line ray and the circle that is given to me, I will say that no solution exists for this question. So guys, if you want to draw this circle more accurately, I will give you a very simple idea. So I know my center, I know my endpoints of diameter. You can get the circle equation directly. So what is the circle equation? X plus 1 the whole square plus y minus 3 the whole square is equal to radius square. What is radius? Radius is nothing but 5 minus 3, which is 2 square, 4 and 1. So it is going to be 5. That's it. So that is the equation of my circle. Now you can draw it perfectly. So however perfectly you draw, it will never go to meet this ray. You can check it out. Clear? So I hope all of you liked the questions discussed today. If you have any difficulty in understanding them, please do let me know. I tried to go slow, and all those who found it a very slow paced, I'm sorry guys, you can go at a faster pace by increasing the speed of this video. You can watch it at 1.5 or 2x, because I think at some questions I spent a lot of time, but that's totally fine because it's good to revise whatever is discussed over here. These are slightly good concepts in complex numbers, and in the next class I'll come up with such good questions from another chapter. And if you have any preference, do let me know in the comments as usual. I will try to bring that particular chapter's questions. Okay? So guys, with that, let's end our session. This is the last question that I had. Thank you for watching, and if you liked it, please do share it to your friends who are preparing for advanced, and if you think it will benefit someone, do share it to them as well. And see you all in the next one. And as I said, if you have any preference of chapters, last time you guys had asked complex numbers and coordinate geometry. So coordinate geometry was taken by Pulkit sir, and complex numbers I am continuing it. So keep it coming. Let me know what chapter you want in particular. We will discuss questions from that. Okay? So take care guys. See you. All the very best. Keep working hard. You guys will do great. Bye bye.